Okay, students, this is the key to quiz 7. So there's only 2 questions on this. It says find the points on this surface closest to the origin. So the trick to this is to minimize the square distance. So the squared distance is going to look like x minus, well, so x naught, y naught, z naught are all 0. So we're minimizing this thing where x, y, z is a point on the surface. Okay, but now we can sub out the y squared with this and reduce it to 2 variables. So that's the trick to it, and now you just set that tangent plane to 0. Okay, z plus, okay, hold on, 2x plus z. Okay, those are your 2 partials, so z is negative 2x. Subbing that in for the z, we can say that 2 times minus 2x plus x is 0. Minus 3x is 0. So x is 0. So z is 0. So y squared is 9, right? Because, yeah. So y is plus or minus 3. Okay, so we found our critical points. So let's go ahead. 0, 3, 0, and 0, negative 3, 0. So now we got to run the second derivatives test. dx is 2. That's dxx. dxy is, or I'm sorry, dxz is 1. dzx is 1, and dzz is 2. So the Hessian is this, which is 3, which is positive. This thing is positive, so both are minima. So those are going to be our answers. Here are the points closest to the origin on the surface. Okay, next question. That one wasn't too bad. Find the extreme values. So this one is going to be a little bit more difficult, but that's okay. So this is a disk, so we've got to see if there's any points inside the disk that are extreme points. So we're just going to use the tangent plane flattening thing. Okay. So x is negative 2. So y is 2. So we're getting the point negative 2, 2, and then 4 plus 4 is 8, minus 8 is 0, minus 8. Okay, we get that. If you look at the Hessian, it's 2, 0, 0, 2, which is 4, which is positive, and then this is positive, so this is a minima. Okay, that's in the disk, right? That's within 9 of the origin for sure, right? Root 8. So now we have to look at the boundary. So that's a different problem altogether. So x squared plus y squared is the boundary equals 81. It's a circle. Radius is 9. So we got to use Lagrange multipliers to do this. So we got to go. Gradient of f is lambda gradient g, where f is x squared plus y squared minus 4x plus 4y, I think is what it was. Okay. And g is x squared plus y squared, and that's set to equal to 81. Okay, so NAMBLA f gradient is 2x minus 4 and 2y plus 4. That's equal to lambda times 2x 2y. So the three equations we get, one of the equations we get is that 2x minus 4 equals lambda 2 equals 2x lambda. The second equation we get is that 2y plus 4 equals 2y lambda. Okay. The third equation is just our constraint. Okay. Now, interestingly, if you you can divide by 2, but look, you can just add these. So if you add them, the 4's cancel, and then you get 2x plus 2y equals 2x lambda plus 2y lambda. So in fact, so killing at 2 gives us this. Notice you can factor that lambda, so if we subtract that off, we get that. Factoring out the x plus y, we get 1 minus lambda. Okay. So either x equals negative y or lambda equals 1. If lambda equals 1, then 2x minus 4 equals 2x, which would say that negative 4 is 0, which is a contradiction. So we have to reject that. Okay, so this must be true. If that's true, then going over to here, we can say that x squared plus negative, let's say negative y squared plus y squared is 81. So y squared is 81 halves. So y is plus or minus 9 over root 2. Okay, then because they are opposites of each other, that implies that x is negative or plus 9 over root 2. They're opposites of each other. So we just need to calculate these numbers. Got to put them in the function. Okay. So let's switch back to this. So let's see, what's another point we got? 9 over root 2, negative 9 over root 2. What is the other coordinate there? If you squared that, it would be 81 over 2. Then you would just do it again. Then you would, okay, well, that's 81, right? And then you would get 36 over root 2. What is that? That's 9 root 2 over 2 times 4 would be 18 root 2. Right. Let me just do it. So it would be 81. And then it's better if it's easier to figure out what these are if you do them as 9 root 2 over 2. Negative 9 root 2 over 2. Okay, so you get 81, and then multiplying by 4 turns that into 18 root 2. And we're subtracting the negative of that again, so it's 36 root 2. Okay. And then the other one would be negative 9 root 2 over 2. 9 root 2 over 2. So we still get 81, but now we would be subtracting 36 root 2. So this thing here was a minimum, and this was a maximum. Okay. All right, I think that's it.